This is video number 5 in a series on John Napier's rhabdology, specifically his Chessboard Abacus, or local arithmetic, as he calls it. This is the 4th or 5th take on square roots. I've just learned it. There will probably be some errors in here. I'm mostly doing this for myself to remember what I've learned so far. So before actually doing an example, I want to explain how the taking of a square root works. So we don't have a number yet. I'm just showing the structure. The first coin is going to need to go on one of these squares along this dotted diagonal. Each of these numbers represents a perfect square. This is in the spot for 1 times 1. This represents 4, which is 2 times 2. This is 16, which is 4 times 4. So these are all the perfect squares. And the first part of our answer is going to be somewhere along that diagonal. The next part of our answer is going to consist of 3 coins known as a gnomon. It's a backwards L shape. So that will either be here, and you literally see it creating a square, or it would be here, like a shell further out, or it would be here. So somehow we're going to get a square, and that second layer is going to involve 3 coins. But then the next gnomon is going to require 5 coins, because they're going to need to match these columns, these rows, and then I need to finish off the bottom. So, oops, I didn't get that in the right row. So as we go, the initial part of our answer will consist of 1 coin, and then 3 additional coins, and then 5 additional coins, and then 7 additional coins. They will increase by odd numbers. So the first example we're going to do is a nice easy number. We're going to take the square root of 36. We know that the answer is 6, so let's see how we get that. These numbers are not in play yet. They're not on the board. It's just a notation of what number I'm working with. I know that my first part of my answer needs to end up on one of these dotted spaces. But as I bring the 32 into play and I slide it diagonally, which maintains its value, it doesn't land on one of those squares. So what I need to do with that 32 is some regrouping. A 32 is equal to 2 16s. A 16 is a perfect square. That's going to land in the right spot. So as I bring that into play and move it up and to the right diagonally, it's going to land on one of those dotted areas. Now I know that for my next move, I will need 3 coins, and I only see 2 coins down there to work with. So I know that I'm going to need to do some regrouping. So let's turn the 16 into 2 8s, and let's see what that gives us. Bring an 8 into play, slide it. We don't want to go above this because that's the top left-hand corner of our square. And I don't want to stay to the left of it because, again, that's the top left-hand vertex of our square. Oh, well, to finish this off, I need my 3rd coin here. Let's see if this will do it. Bring it into play, slide it diagonally, sure enough, and you literally see a perfect square. What you're seeing here, it's the rectangular area model of multiplication, basically. But we've got 4 plus 2, which is 6, times 4 plus 2, which is 6, and that gives us our 36. So the square root of 36 is 6, which I can read right here. So I'm going to try a larger number. Let's go with 196. Part of the challenge here is to write the number in binary. That's not what Napier would have called this. It's not how he would have thought about it. But you're basically subtracting out powers of 2. So 196, it's got a 128 in it, it's got a 64 in it, and it's got a 4 in it. So if you add all of these up, you're going to get a 196. So let's bring the 128 into play. That does not land on the diagonal that I need. So I'm going to do some regrouping. I'll replace a 128 with 2 64s. So I now have 3 markers in the 64s place. That is a perfect square. So when I slide it, it's going to land on one of the dotted spaces. 8 times 8 maintains that value of 64. So if I try to use the 64, I don't want to be, again, to the left of my square, and I don't want to be above it. So that's not going to work. I'm actually going to regroup this 64 by doubling each of those coins and moving one to the right. 2 64s is the same as 4 32s. And for the next stage of my diagram, I need a gnomon made of 3 coins. So let's work with the 32. Well, that looks good. That's at the top of my square. That looks good. That's on the left-hand side of my square. So I need one that's here. Well, the 32 isn't going to do that for me because any 32 is going to be in this diagonal. And I would need something below that and to the right over here. So I'm actually going to regroup those as well. And instead of 2 in the 32 spot, I'm going to have 4 in the 16 spot. Actually, I think I jumped the gun a little bit. I do need to finish off that first gnomon. So I've got 1 coin for my first step and 3 coins for my second step. So the regrouping worked well. I was a little bit ahead in what I was saying. So let's see what happens if I continue to use the 16. Can I get what I need? Well, as I move this along the diagonal, I can get one there on the top of the square. I can get one here on the left-hand side, which looks good. I can't continue using the 16. Actually, I know where the rest of my coins need to go. I need an L shape that's going to help me form a square. 2 coins here, I need 3 more for a total of 5. So I need to regroup the 16 to be 2 8s. I bring those into play. And then I bring this 4 into play. That completes my square. Remember, I was taking the square root of 196. Well, this is 8 plus 4 plus 2, which is 14. This is 8 plus 4 plus 2, which is 14. 14 times 14 equals 196. So there's your square root. 842, 14 is the square root of 196. I'm going to try one that's more challenging, and this is why this is my 4th or 5th take on this video. So let's see if I can get it right this time. Whether I do or not, we're just going to keep rolling. So I'm going to use 1,238. I want to take the square root of 1,238. I'm going to estimate it to the not the nearest whole number, but the whole number that I could square to get the closest square underneath 1238. So 1238 is 1024 plus 128 plus 64 plus 16 plus 4 plus 2. And I do have some paperwork off to the side where I've done the subtraction. So I just want to double check that. I've got 1024, I need a group of 128, a group of 64, 16, 4, and 2. You can pause the video, add those up, and you'll see that you come up with 1238. So I grab the 1024 and I move it along the diagonal. It does hit one of the spots that's marked with a dot, so that's good. One of the things I've realized as I've been doing this is that I really need 2 coins in the same place value in order to get the other 2 corners of my square. They have to be on the same diagonal. So I'm going to go ahead right now and replace this 128 by 2 groups of 64. Because when I do that, I can slide along this diagonal and come up to the top of the square. And when I slide along the diagonal again, I get something that's starting to shape a square. I get the other 2 vertices or the other 2 corners of my square. So to finish this, my 3rd piece in the first gnomon is going to need to be a 4. It has to go here in order to complete the square. And I have a 4, so I'm going to bring that into play. But now I need to try to make another diagonal. My next one is my next gnomon needs to have 5 coins in it instead of 3. So I'm going to regroup this 64 into two 32s so that I can get two coins that are on the same diagonal. So I bring a 32 into play and I slide it along. There's really only one place left to put it because the only space I have left to make the next gnomon is out here on the right-hand column and on the bottom row. I bring this other 32 straight into play and there's no sliding needed. Now I can actually see where the rest of my coins need to go. They need to be in this row and this row because that's where I have my other coins. I'm not going to get there using this 16. Right? I have a 16, but I actually need my other three coins to be here. So I'm going to regroup the 16 to an 8. That still doesn't get me here where I need to be. So let's regroup one of the 8s. Take away one of these 8s and replace it with two 4s. And with a 4 as well, that doesn't get me, you know, if I bring a 4 in and I slide it over to this column, that's no good because there are no other coins in that row. So let's bring that back. I'm going to take one of these 4s and regroup to give myself two additional 2s. Let's use the 2s. Get it on the board, slide it, get another one on the board. Those are in place. And I need something right here to finish off that gnomon and to finish off my square. So the 2 gets regrouped as two 1s. That slides onto the board. And so I've got some things left and I can't use them because if I try to continue this square, I'm going to go off of the board and be on the right-hand side. So this ends up in some sense being a remainder. So what this is telling me right now is that the square root of 1,238 is approximately, let's move these out of the way, 35. 32 plus 2 plus 1, 35. What does it mean that I have these left over? Well, what it means is that 1,238 is equal to 35 squared plus 13. 8 plus 4 plus 1. 1,238 equals 35 squared plus 13. So you might wonder, well, you know, what about decimals? Can you go further? Can you bring this into decimals rather than just estimating in this way? And you can, but the thing is you have to multiply the number by 100. So if I wanted to get a decimal approximation to the 10th place of this number I was just working with, I would have to create the number 123,800. And that's a little bit off my board. I could make a bigger board and I could do it, but it's only going to gain me one decimal place. So let's try one more example. I want to take the square root of 2, and I want to get that, well, let's first of all see if we just try to do that. So 2, we bring it onto the board, but as I slide it diagonally, it doesn't hit one of the dots. So I take that 2, and I regroup it as 2 in the 1's place. Bring that onto the board, it's on a space with a dot. Yeah, that's great. So that tells me that 2 is equal to 1 squared plus 1, and that's true. But let's say that I want to take the square root of 2 and have it accurate to one decimal place. What I would do is, instead of working with a 2, I would work with a 200. And then when I get my answer, which is going to be 14 something, I would put the decimal where it needs to go. I know that the square root of 2 is 1 point something, so that 14 becomes a 1.4. So let's see what that looks like. So 200 is equal to 128 plus 64 plus 8. Okay. So 128 plus 64 plus 8, that's going to give us 200. And I decided on that because I took the 2 and I multiplied it by a 100 because I'm working with place value. And the square root of 100 is 10. It's going to give me the decimal in the 10th place. So continuing the process as we've been doing, the 128 doesn't hit the dotted line. So we bring that back, we regroup, and rewrite it as 2 markers in the next place down. 64 is, of course, a perfect square, so it's going to land there. I am trying to make a gnomon of 3 markers. So let's see what happens. If I grab the 64, yeah, that's on the left-hand side of my square. This is above my square. That's not going to work. So I want to go down to the next place, and I'm going to double all of those. The 2 markers on the 64 are going to become 4 markers on the 32. We'll bring one of those into play, slide it diagonally, bring another one into play, slide it diagonally. That gives us the first 2 pieces of our L-shaped gnomon. I need one to land here. I'm not sure. One of the things I'm still trying to figure out is whether I always want to double both of these and bring 4 down to the next level, or if I just want to take one and regroup. But let's go ahead and regroup both of these 32 markers and get 16, or 4 in the 16th place. So as I slide, I'm going to get that second level of my square. I've got the upper corner here, upper left-hand corner, and then I have that L shape. So let's see what I can do with another 16. Can I use those? Yeah. I can slide those right into place. I know my other markers need to go here, but how am I going to get that using the coins that I have? I need 3 more, so I will need to do some regrouping. I can't use the 16 again because that diagonal is already filled up within the square. So I'll regroup the 16 to 2 8s, and I'll slide those into place. This 8, again, I can't use that. It can't go here, it can't go there. That would be outside of my square. So I'm going to regroup the 8 to 2 4s. I'll slide that into place. Now we do have a remainder. You know, this didn't go in perfectly. But the square that I have here is the result of 14 times 14, which we know from earlier is 196. It's pretty close to 200. Had I multiplied by 100 again and been using the number 20,000, which I actually could have done with this chart because it goes all the way up to 16,384. I just didn't feel like taking the time. But what we've got here is we can approximate the square root of 2 to be 1.4 because the square root of 100 is close to 14. And when we divide out that 100, because we've taken the square root, that's actually a 10. And so we're going to move that decimal 1 space over, and we get 1.4.